Now we can find the hybridization if we know the steric number. So for example, this carbon atom has a steric number of 3. So we know that the hybridization of that central carbon atom must be sp2 hybridized. Here we see a double bond between the carbon and the oxygen. So one of those bonds is a sigma bond and the other one is a pi bond. The sigma bond is always the one that comes along the internuclear axis, which is where that hybridized sp2 orbital would point. So the sp2 hybridization gives us 3 sp2 orbitals. One of them is used to make a bond with the hydrogen on the left. The second one is used to make a bond with the hydrogen on the right. And the third one is used to make a sigma bond with the oxygen at the top. The double bond comes from the overlap of unhybridized p orbitals, one on the carbon and one on the oxygen. They overlap, and that's going to make the pi bond. The question is, what's the hybridization of this oxygen atom? Is it hybridized or is it not hybridized? We did not hybridize the hydrogen atoms because they didn't need to be hybridized to explain the shape of this molecule. And because oxygen is terminal, the only way we can figure out the hybridization is to know the angles between the atoms. We can't measure the angles between electrons the way we can measure the angle between atoms in chemicals. So for example, we know around this carbon that these angles are about 120 degrees for our trigonal planar geometry. It's difficult to measure the angle of the oxygen because 2 out of the 3 components that we would be measuring are just non-bonding pairs of electrons. So in a picture like this, we may not be able to assign a hybridization to that oxygen atom. However, the same chemical might make a bond, for example, with a hydrogen, and now we could look at this oxygen and we know that this oxygen has 3 regions around it. It has a steric number of 3, 2 ligands, the carbon and the hydrogen, and 1 lone pair. So now we could measure this angle and we would find it's about 120 degrees. So we could say that this oxygen is sp2 hybridized. For that reason, some people will assign a hybridization to that oxygen. They would also call that sp2 hybridized, because notice there are 1, 2 lone pairs, 1 ligand. That's still a steric number of 3.